Today is the third problem solving session for the course Environmental Chemistry and Microbiology. I'm Shrija Ghosh, a PMRF from IIT Kanpur, and the course instructors are Professor Anjali Pal and Professor Sudha Goyal from IIT Kharagpur. Till now we have discussed acid, bases, and salts, and we have discussed in the last class we had discussed chemical equilibrium, right? So today we'll discuss about another topic, that is chemical kinetics. So I'm sure you all must have gone through the lecture videos and your week 3 assignment. So today I'll be discussing certain questions which are related to your third week's assignment. And let me know if you have any doubt in any of the question. You can either write it in the chat box or you can unmute your mic and ask me. Okay. So I hope my screen is visible. So I'll start with the first question. Yeah. Yeah. So before starting with the question, I just want to brush up through the concepts of kinetics and different orders of reaction. So in chemical kinetics, we basically measure the rate of the reaction. Okay. So if there is a reactant and that is forming some sort of product, if a reaction is going from A to P, the rate will be defined as the conversion of reactant to product in a certain amount of time. Okay. So that would be either decrease in the concentration of A with respect to time or increase in the concentration of the product with respect to time. So rate can be written as negative dA by dt, where A is the concentration of A, or it can be written as a positive dP by dt because P is forming here. So the amount of P will increase. So change in concentration of P will be positive, but change in concentration of A will be negative because it will go from a higher value to lower value. It will reduce. Okay, so it will go in negative. So that's why the negative sign. Also, the rate is also defined as K into the concentration of A raised to the power of N, where K is the rate constant, reaction rate constant. So it is different for every order of reaction, and N is the order of reaction. So what do we mean by order of reaction? So let's say it's a zero order reaction. That means the value of N will be zero here. So the rate will be K A to the power of 0, and you know anything to the power of 0 is equal to 1. So rate will be equal to K. Now, if you further solve this equation, if you integrate the equation on both sides, you will get this. That is the final concentration of the reactant minus the initial concentration of reactant will be equal to minus Kt. Okay, where T is the time taken for the reaction to occur. So here you can see, since the rate is independent of the concentration of the reactant, you can see rate is, here the rate is a constant value. K is a rate constant. So K is a constant value. So the plot that you will get here for a zero order reaction would be a straight line. So if I plot, so if I make a plot now of the concentration versus time, it would be a straight line. It would be a straight line because with respect to time, there will be no change in the concentration of the reactant because the rate is independent of the concentration of A. Rate is constant for a zero order reaction. Now, if we see for the first order reaction, If you see for the first order reaction, you will find the N will be 1 and your rate will be K multiplied by the concentration of A. So if you again rearrange it and then integrate it, you will find log of initial concentration by final concentration is equal to Kt. So here, if you plot it in a graph, so if you make a plot of log A, log of the concentration of reactant versus the time, you will find a linear curve. You will find a linear curve.
Okay.
For a second order reaction, the value of N will be 2 and the rate will be K multiplied by the concentration of A square. And if you again integrate it, you will get another equation, which is a equation for a
Equation.
straight line. So starting with the questions now, question number 1. An experiment was conducted to find out the rate of a chemical reaction. The concentration, which is in kg per liter, was measured at different times and the data were plotted as follows. So you can see here the x-axis shows time, that is shown in day, and y-axis has 1 by c. Okay, and we have the equation given, which is a straight line equation. So the order of reaction and the corresponding rate constant are as follows. Now you have to select which of the following option is correct. So first thing in such questions we have to notice is the equation that we have. So here we can see it's a straight line equation. So what is a straight line equation? Y is equal to mx plus c, where m is the slope, c is a y-intercept. So you can see y is 1 by c here. So we have 1 by c equals 0.0541. So this will be the slope. X is t time plus we have 0.05, which is the y-intercept. So this is a straight line equation. And if you see from the previous slide, this equation resembles the second order rate equation. That is, if this is the y-axis, so if we plot this, so 1 by A will be the y-axis and t will be the x-axis. So this is similar to the second order reaction. So we have two options here for second order reactions, right? So now we have to see what would be the rate constant. Now, if you again see this equation, k is the rate constant. So that is the slope of the straight line. So the rate constant is 0.0541. Now 0.0541 is again there in both the options. So now you have to pay attention to the unit that is there. If you see here, so for rate, we have change in the concentration of the reactant with respect to time. Okay, with respect to time is equal to the K into the concentration of A raised to the power of 2, because it's a second order reaction, right? Now you just have to see the units of each of these values. So concentration is given in kg per liter. Here the concentration is given in kg per liter. Time is given in day. So if you see, concentration will be kg per liter and then time is day. Time is in the denominator. So I'll just write it in the numerator in the inverse form, is equal to K multiplied by kg per liter whole square. Okay, so the unit of K will be equal to kg per liter per day divided by kg square and liter minus 2. So if you see, this will get cancelled out, this will get cancelled out, and you will have liter inverse kg, sorry, you will have liter kg inverse and day inverse, right? Okay, so that is the unit here. So if you see in the option, the fourth option is the correct answer because the unit for the rate constant is correct in this case. Is that clear? Okay. So moving on to the next question, question number 2. The radioactive nuclide P32 has a half-life of 14.3 days. What fraction approximately of the initial P32 will remain after 84 days? Radioactive disintegration follows first-order kinetics. So here we have the half-life given. Okay, half-life means the time taken for the reactant to convert into half of the product. So if I start with, let's say, 100% substrate, so if the reaction is something like A goes to B, and if I start with 100% A, so the time taken for A to convert into the time taken for 50% of A to convert into B will be the T half of that reaction. Okay, so the time taken for 50% of the starting material to get converted into the product will be the half-life of that reaction. Okay, so now they have asked what fraction of the initial P32 will remain after 84 days. Now to solve this, they have mentioned that it is following a first order kinetics. So from the first slide, we know that now that the first order kinetic equation is log initial concentration divided by the final concentration is equal to kT. Now I told you half life, uh, that is the T half, that is the time in which the initial concentration will be the 50%, sorry, the final concentration will be the 50% of the initial concentration. Okay, so if that is the case, then you will have, if the initial concentration is 100, then the final concentration will be 50, right? So in this way, the log C0 by C will become log 2. This will be 2, right? So this will be natural log 2, and this is equal to K T half. So this is the half-life. So half-life is already given in the question. So half-life is given as 14.3 days. Okay. And the value of log 2 is 0.693. So now to solve from this, we can easily solve for the rate constant. Okay, so the rate constant will be 0.693 divided by 14.3, right? So this is how from the half-life we can easily calculate the rate constant for a first order reaction. Okay, once you have the rate constant, now what's the next part of the question? The next part of the question is what fraction of the initial P32 will remain after 84 days, right? So what fraction of initial P32 will remain after 84 days? For that, basically, we have to see the ratio of C0. Okay, so now here we have the value of K, we have the value of T. T is 84 days. C by C0 we have to calculate. So C by C0 you can easily calculate. Uh, yeah. So the equation is ln C0 by C is equal to KT, right? So if I take this natural log to the other side of the equation, this will be C0 by C is equal to e raised to the power of KT. Okay. Or if I inverse this now, so C by C0 will be equal to e raised to the power of negative KT. Okay. So the value of E is around 2.7. Okay. The value of E is around 2.7. So you can easily calculate for C by C0 what would be the ratio after 84 days, because you have the value of K, you have the time given, and you can easily solve this equation using your calculators. Okay, so what is the so whatever number we are getting, we just have to multiply it with 100 to get the percentage. And what is the percentage we are getting? That is 1.7%. So you can also calculate this on your own. So 1.7% is the fraction that will remain of the initial P32 after 84 days. Okay. So here we had the half-life. So after 14.3 days, 50% was remaining. After 84 days, only 1.7% will remain. Okay. So this is how you can calculate for such question. This is clear to everyone? Moving on to the next question. Consider the reaction 2A plus B goes to product. The rate of the reaction is 4.8 into 10 raised to the power of minus 4 mg per liter per hour. If A is equal to, if the concentration of A is equal to concentration of B, and that is equal to 0.4 molar, and rate constant at 300 Kelvin is 3 into 10 raised to the power of minus 3 liter per mg per hour, what is the overall order of the reaction? So here you have the reaction given as 2A plus B goes to P. So you have to find the order of the reaction. So any reaction when given, I told you the rate is defined as K into the concentration of the reactants raised to the power of the order. This I've told you in the first slide. So K is the rate constant. K is the rate constant. This is the concentration of reactants, and this is the order. So in this question, what do we have to find? We have to find the order. So we have to find this n. So for this equation, since there are two reactants, for this equation, the rate will be K A raised to the power of n multiplied by B raised to the power of m, and the order will be n plus m. Order will be defined as n plus m. Okay, so we have to find n plus m. Now, what is given in the question? The rate of the reaction is already given for a particular concentration. So, when the concentration of A and B are 0.4 molar, the rate is 4.8 into 10 raised to the power of minus 4. So, you can replace the values here. 4.8 into 10 raised to the power of minus 4 is equal to K 0.4 into n, raised to the power of n multiplied by 0.4 raised to the power of n. Now the base is same, so we can write it as K into 0.4, and K is also given. K is also given here. So replace the value of K. So replace the value of K. This can be written as 0.4 n plus m multiplied by, what is the value of K? 3 into 10 raised to the power of minus 3. Okay. This is equal to 4.8 into 10 raised to the power of minus 4. Now you can solve this. So once you solve this, you will get, so once you solve this, basically you have to take this on this side of the equation, and you will get 0.16. Now this is 0.4 raised to the power of n plus m. and on the other side we are getting 0.16. So 0.16 can also be written as 0.4 raised to the power of 2, right? So that means n plus m is nothing but equal to 2. That means the order of the reaction is 2, or we can say it's a second order reaction. Okay, this is clear to everyone. So basically whatever the reaction will be there, you have to define the rate as the rate constant multiplied by the concentration of reactants raised to the power of the power. Okay. So rate will be equal to rate constant multiplied by the concentration of reactants raised to the power of the order of the reaction. Okay. So here we are getting this as second order reaction. Any doubt in this question? Let me know if you have any doubt. You can write it in the messages, or you can ask me by unmuting your mic. Okay. Moving on to the next question. The rate law for a reaction involving the reactants X, Y, and Z is found as rate is equal to K concentration of X multiplied concentration of X cube multiplied by concentration of Y raised to the power of 2 by 3 multiplied by concentration of Z. How would the rate of reaction change when the concentration of X is reduced to X by 2 and Z is octupled, that is Z is increased by 8 times? Okay, so what would be the change in the reaction rate? So here we have a rate equation given. Okay, what is the rate equation? We have a rate equation given as K x raised to the power of 3, y raised to the power of 2 by 3, and z raised to the power of 1. Okay. Now, what is the new x? So, new x is now x by 2. Okay. And what is the new z? New z is 8z. Okay. So, now what would be the new rate equation? So, I'll write it as rate dash. So, new rate equation will be K x by 2 cube multiply y. There's no change in y, so we'll write the y as it is, and z and 8z. Okay. So this is the new rate equation. We can also write it as, now 2 cube is 3, so this will be x cube, and 2 cube is 8, so this will be x cube, and we can take the 8 outside, and then we can write it as y raised to the power of 2 by 3 and z, and we can take the 8 from the numerator also outside. So this will get cancelled and the new rate will be equal to the old rate. So that means the rate of the reaction when the concentration of X is half and the concentration of Z is 8 times increasing, the rate of the reaction is remaining the same. Okay. Do you understand? So here's the solution. So the initial rate, that is the first rate that is given in the question, is K multiplied by X to the power of 3, Y to the power of 2 by 3, and Z. Now what is the new X? New X is X by 2. New Z is 8Z. So the second rate equation will be K X by 2 whole cube. Now X by 2 whole cube means 2 cube is 8. So 8 will come out as denominator. Y raised to the power of 2 by 3, y, there's no change in y, and then 8z. So there is a 8 in the numerator and in the denominator. So 8 will get cancelled out and we will get the new rate which is same as the old one. Okay, this is clear to everyone. So the correct answer is the rate of the reaction remains the same. This is clear. Okay, moving on to the next question now. When Cl2O7 decomposes at 550 Kelvin in the gas phase to form Cl2 and O2, it follows a first order kinetics. After 2 minutes at 550 Kelvin, the pressure of the Cl2O7 falls from 0.1 to 0.05 atmosphere. What is approximate rate constant? So here it is following a first order kinetics, right? So again, we'll use the formula for first order kinetics. What is given in the question? What is given in the question? In the question, we have the time given. We have the initial and the final pressures given. We have to find the rate constant. So this is easy. You just have to use the first order rate kinetic equation. So remember, we had log C0 by C is equal to KT. So here we have the T, we have the initial and the final pressure. We just have to find the K. Okay. So you have log C0 by C is equal to KT. So K will be equal to, so this is log C0 by C, right? So if you inverse this, so this can also be written as ln C0 minus ln C, natural log of C0 minus natural log of C. And this, if I now flip it, if I take it on the other side of the equation, if I write it as ln C minus ln C0, this will be equal to minus KT, right? And this can also be written as ln C upon C0. This is equal to minus KT. So that is why when you change the numerator and denominator inside the log, the sign will be reversed. Okay, so this was C0 by C. Here we have C by C0. So this is how you get that negative sign here. So you have negative 1 by T ln C by C0 because the T will come on the denominator on this side. Now you just replace the values. So T is 120 minutes. 120 seconds. 2 minutes, right? So in the answer, you see the options are given in seconds. So that's why we have to convert it in seconds. So T is 120 seconds. C is initial concentration is 0.1. So the pressure of Cl2O7 falls from 0.1 to 0.05. So initial is 0.1, final is 0.05. So 0.05 divided by 0.1. Okay. Now you solve this. It's very easy to solve. Just divide 0.05 by 0.1 and then just take a log of that, natural log of that, ln, and once you take natural log of that, divide it by 120. Okay, divided by 120 and you will get the answer as 5.78 into 10 raised to the power of minus 3, which is option B. Okay, so option B is the correct answer here. So I request all of you to do the calculation on your own. If you have any doubt in the calculation part or in the question itself, let me know. Is this question clear to everyone? Okay, so we had the initial and the final pressure given. We had the time given. We just calculated for K. If this is clear, we can move on to the next question. Next question is 2A plus B goes to C. For the reaction, find the rate law from the following table. So here we have three different rates given for three different sets of reactant concentration. So when concentration of A is 0.3 and B is 0.03, the rate was 0.25. When the concentration of A is 0.3 and B is 0.06, the rate was 0.5. And when the concentration of A was 0.9 and concentration of B is 0.06, the rate is 4.5. So we have three different sets of reaction rates given. From this, we have to find the rate law. So we have to find a generalized equation. So remember, I told you that the rate of any equation is defined as K multiplied by the concentration of the reactants raised to the power of the order. Okay. So here we have two reactants and the order of the reaction will be N plus M. Okay. So this would be the generalized reaction rate. Okay. So now here for the first uh, equation we can write rate is 0.25 K multiplied by concentration of A is 0.3 raised to the power of N and 0.03 raised to the power of M. Okay, this is fine. This is the first equation. For the second one, we can similarly write 0.3 is equal to K, sorry, 0.5, the rate is 0.5, right, is equal to K multiplied by 0.3 raised to the power of N multiplied by 0.06 raised to the power of M. Same thing we can do for the third one where we have 4.5, the rate is 4.5 K multiplied by 0.9 raised to the power of N and 0.06 raised to the power of M. Okay. So just divide. If you just have to find the value of N and M, right? So if you find the value of N and M, you can find which of the rate equation is correct, right? So for that, you have three equation and uh, three unknowns. So you can easily solve this thing. So what you have to do is you have to first divide any of the two equations. Okay. So let's divide the third equation by second. So if we do that, we'll get 4.5 by 0.5 is equal to K 0.9 raised to the power of N 0.06 raised to the power of M. And for this is K 0.3 raised to the power of N and 0.06 raised to the power of M. So this is the same thing. So this will get cancelled out and K will get cancelled out and 4.5 by 0. So 4.5 by 0.5 will be equal to 9. Okay, 5 nines are 45 and this will be 0. This will be 3 raised to the power of N. So we know that 9 is equal to 3 raised to the power of 2, right? So that means N is equal to 2. Okay. Similar, now we know N is equal to 2. That means A is equal to A raised to the power of 2. Now if we want to solve for B or solve for M also, we can again divide two of these equations. So we can divide these two equations. Okay, we can divide these two equations. So 0.5 divided by 0.25. Okay, and we can divide these two equations. So the fact n factor will get cancelled out and you can solve for m. And you will find the value of m to be 1. Okay, so the rate equation will be k a square and b. So you can see here. So we have the rate as k a raised to the power of m and b raised to the power of n. And we have three equations. So first equation is 0.25 is equal to k multiplied by 0.3 raised to the power of m and 0.03 raised to the power of n. Similarly, we wrote the other two equations. Now we just have to solve for m and n. Okay, so we just have to replace the values of m and n here. So to solve for m and n, you can see that these two factors are same. So if you divide this, this will get cancelled out and you can easily solve for m. So m is equal to 2. Now again, if you divide these two equations, the first and the second equation, if you divide second by first equation, these two factors will get cancelled out and you will solve for n that is equal to 1. Okay. The rate equation will be k concentration of A raised to the power of 2 and multiplied by concentration of B. This is clear to everyone? Is this clear to everyone? If you have any doubt, please write it in the chat box or you can unmute and ask. Anybody has any doubt? Okay. If there's no doubt, then I can move ahead. So consider the following reaction. 2O3 goes to 3O2. The rate of appearance of O2 is 4.25 liter per second over the first 6 seconds. How much oxygen will be formed during this time? Okay. So the reaction is ozone is getting converted into oxygen. The rate of appearance of oxygen is 4.25 liter per second over the first 6 seconds. So time is given, rate is given. Okay. How much oxygen will be formed during this time? So you have to tell the amount of oxygen, amount of product that is forming during this time. So here if you see, the rate of appearance of O2 is basically change in the concentration of O2 with respect to time. And that is what we have to answer. So how much oxygen will be formed during this time? So this will basically be uh, rate of appearance of O2 will be equal to dC by dt, and dC, that is the change in concentration of O2, that is the concentration of generated O2. So just multiply the rate with the time and you will get the uh, amount of oxygen formed during this time in liters. Okay, so the answer is 25.5 liters. So 4.25 multiplied by 6 seconds. Okay, this is clear to everyone. This is a very simple question. Okay, moving on. In a study with a groundwater sample, it was observed that tetrachloroethylene, that is TCE, is degraded following the first order kinetics with a half-life of 144 hours. If the current groundwater concentration of TCE is 14 microgram per liter, how long will it take before the TCE concentration is reduced to drinking water standard of 2.5 micrograms per liter? Okay. So we have in the question, we have the half-life given. So I told you for a first order kinetics, we can easily calculate the rate constant if the half-life is given. How? For a first order kinetics, log of C0 by C is equal to KT. This is the general formula. Now, what is half-life? Half-life, I told you, half-life is the time taken for the 50% of the reactant to get converted into the product. Okay, so the initial concentration of reactant, if the initial concentration of reactant is 100, then the time taken for the the time taken for the 50% of the reactant to get converted into product is the half-life. So that means if the initial concentration is 100, the final concentration will be 50 and the T will be T half basically. And this is equal to 2. So half-life is actually equal to natural log of 2 divided by the rate constant. Okay. So natural log of 2 is 0.693 divided by, so from this we can calculate K. So T half is given. T half is what? 144 hours. Okay. So we can calculate for the rate constant. Now, once we have the rate constant, what is the next question? Next part of the question. Next part of the question is, if the current groundwater concentration of TCE is 14, how long will it take before the TCE concentration is reduced to drinking water standard of 2.5 microgram per liter? So basically, you have the initial concentration, you have the final concentration, you have the rate constant. So now you have to calculate for T. So rate constant you can calculate from here. Then again you have to put these values in the equation. So now this will be 14 by 2.5 is equal to the rate constant, whatever you are getting out of this, 0.693 divided by 144 into T. So now you can easily solve for T, right? So I request all of you to solve for T. Yeah, so we have one answer, option C. Others also do the calculation. So here's the solution. So the correct answer is option D. So from the half-life, we first calculated the K. The K was coming to 4.81 into 10 raised to the power of minus 3. Okay. Then you again have to put these values in this equation. So you have the K as 4.8 into 10 raised to the power of minus 3. And then you have the initial concentration as 14, the final concentration as 2.5, the value of K. Solve this and you will get the answer for T. So just divide 14 by 2.5, take a natural log of that, and then divide that by 4.8, and then multiply by 1000. Is that clear? Are you able to do this calculation? You will have a digital calculator during your exam also, so don't worry about that. You can use your calculator for calculating this. Is this clear? I want everyone to do the calculation part on your own so that you will also understand the solution. If you have any doubt, please ask. Okay. Okay. I'll move on to the next question. The half-life of 2,4-D, whose degradation follows a first order kinetics, is estimated to be approximately 14 days. Now, again, the half-life is given 14 days. How long would a waste containing 20 mg per liter of 2,4-D have to be stored in order to reduce the concentration to 0.5 mg per liter? So 2,4-D gets degraded following a first order kinetics. Okay. So the half-life is given. So from the half-life, what we can calculate? We can calculate the rate constant, right? So from the half-life, we'll calculate the rate constant. The rate constant K will be 0.693 by 14. Okay. And then using this rate constant, you can, to solve this, whatever K value you are getting, you just have to replace it. So this will be log. So initial concentration is 20 and the final concentration is 0.5 because it is getting reduced from 20 to 0.5, and this will be divided by K. So this will be the time taken for the 2,4-D to get reduced from 20 mg per liter to 0.5 mg per liter. Okay. Is this clear? So we have one answer, option B. Anyone else wants to answer? If you are able to solve this, I would encourage you to write the answer in the chat box so I'll also know how many people are understanding it. Okay. So B is the correct answer. Here's the solution. So you can see in the solution. So we solved for the rate constant. Just like I told you, 0.693 divided by 14. So the rate constant is coming as 0.0495. And then you just have to replace the rate constant in the rate equation to get the time. So time taken for the 2,4-D to get degraded from 20 mg per liter to 0.5 mg per liter. That is 20 is the initial concentration and 0.5 is the final concentration. So this will be divided by the rate constant, that is 0.0495, and once you calculate the whole thing, you will get the answer as 74.5 days. Okay. I hope this is clear to everyone. Everyone is able to solve this. Then I'll move on to the next question. It is found that the disappearance of we have the initial concentration and final concentration. What we have to solve? We have to solve for the rate constant. So this is again very simple. You just have to replace, put the values in the rate equation. Yes, we are getting different answers. So we have three different answers, C, D, and A. So let's see which option is correct. So what you have to do, you have the rate equation, right? So what all is given? The initial concentration is given as 150. The final concentration
మన
is
గురించే
given as
చెప్తున్నారు.
and we have to solve for K, and the time is given as 20 seconds, right? So just solve this. Just divide 15 by 6 and then take a natural log of that and then divide by 20. So the answer is 0.046 seconds. So per second. 0.046 per second. That is option C. So Suartha Joshi answered it correctly. Option C. Others, I'm assuming, would have done some calculation mistake.
మేడం మన గురించే చెప్తున్నారు.
So I hope everyone is understanding this question. Is there any doubt in this question? Apart from the calculation mistake, are you able to understand the concept of this question or not? That is more important. Okay. Okay, great. Okay, if you are able to understand this, I think I can move on to the next question. Let a first order reaction is 12.5% complete in 45 hours. To have 75% complete, it will take approximately. So you have to calculate the time. So what all information do we have? We have the information that it's a first order reaction. So you know you know which equation you have to use. It is taking to 45 hours to complete 12.5% of the reaction. Okay. So in a way, in this statement, they have told you what is the initial and the final concentration. Okay. So let assume that the initial concentration is 100. So that means final concentration will be 100 minus 12.5 because 12.5% reaction is complete. What does it mean? That means if we start with 100%, from that 12.5% of the starting material has gotten converted into product. Okay. So from 100, 12.5% is complete. So the initial concentration, if we are taking it as 100, the final concentration will be 100 minus 12.5, that is 87.5, right? So now if I tell you that the initial and the final concentration are these and the time is given, you can easily calculate for K, right? And once you calculate for K, now what is the question? They have asked you to have 75% complete 75% of the reaction to be completed. It will take approximately how much time, right? So you have to calculate for the time. So you can calculate for K here. So you can just do log 100 by 87.5 divided by 45. So this you will, whatever you will get from this will be in R inverse. Okay. Then you just have to calculate the time for 75% of complete reaction. Now 75% reaction completed, that means if C0 is 100, C will be 25, right? Because 75% of 100 is converted into product. So what is the remaining C? Remaining C will be 25. So again, you can use it in the equation, and now you from this you will already have the value of K. So you can calculate the value of T. This is clear? Anybody anybody is able to solve this? Do the calculation. Just keep in mind that whatever answer you will get after this, you just have to convert it into days. How will you convert from hours to days? Just divide it by 24. One day has 24 hours, right? So whatever hours you are getting, just divide it by 24. Okay. So Suvartha has answered option A. Anyone else is able to calculate? Anyone else is able to finish the calculation? I've told you how to solve this. Just take your pen and paper and solve this. Just solve for K and then again solve for the time taken for 75% completion. So here's the solution. So option D is the correct answer actually. So Suvartha, I think you might have done some calculation mistake. You can recheck your calculations once. So you have first order reaction equation is natural log of C0 by C is equal to KT, right? So if C0 is 100, when 12.5% reaction is completed, that means C will be 100 minus 12.5, that is 87.5. Okay, and T is 45 hours. So you have log of 100 divided by 87.5, the whole thing divided by 45. So we are getting 0.00297 hours inverse. Okay. Now for 75% reaction, the C will be 25. So again, you can solve this. You just have to replace the value of K with this and you can get the time in hours. And what is the time? We are getting 466.7 hours. Now 466.7 hours is approximately equal to 19.45 days. You just divide the hours by 24 and you will get the answer in days. Okay. So there's a lot of calculations involved in these type of questions, even in the last class when we were discussing chemical equilibrium and for kinetics. So just be careful with these calculations because even if you're correct with the concept, might be getting the wrong answer ultimately. Again, the answer is option D. I hope everyone is able to get the answer. Is there a calculation mistake on my part? Let me check. 466.7. Yeah, the answer is 19.45, 9.45. Yeah. Hmm. 19.45 is the correct answer. So option D is the correct answer. Okay. Anybody has any doubt? So we move to the next question. Question number 12. Consider the reaction B goes to C. It is found that the rate of the reaction increases by a factor of 4 when the concentration of C is quadrupled. The reaction is, you have to tell the order of the reaction. So you have the reaction B goes to C. I told you the rate of the reaction is written as rate of any reaction is written as K multiplied by the concentration of reactant, in this case B, to the power of N, where N is the order of the reaction. Okay. So N is the order of the reaction. Now here, what information do we have? They have said that the rate of the rate of the reaction is increasing by a factor of 4 when the concentration of C is quadrupled. So either you can write the rate like K multiplied by concentration of B raised to the power of N, or you can also write it in terms of concentration of C, because what is happening, the rate of the reaction is basically how fast uh, one thing is changing into another. So if the reaction is B goes to C, so the change of concentration of B with respect to time, or the change of concentration of C, because B will reduce and C will automatically increase because B is getting converted into C, right? So change in concentration of any of the, either the reactant or the product with respect to time will be defined the rate of the reaction. So you can either write the rate as uh, rate in terms of the concentration of B, or you can also write it in terms of the concentration of C raised to the power of N. So this is also correct. So now what information do we have? They are saying that when C is quadrupled, what do we mean by C is quadrupled? The concentration, now the new concentration is 4 times the initial concentration. Okay. And when the new concentration is increased by 4 times, the rate is also increasing by 4 times. Okay, so the new rate is also 4 times the old rate. Okay, so what you have to do, you just have to write two different equations. So this equation will be equal to, so the new rate is equal to K into 4C raised to the power of N, right? So this can also be written as 4 K C raised to the power of n. 4 raised to the power of n is outside. Okay. And we can write this as 4 raised to the power of n, and kc to the power of n is equal to the old rate, right? So this is equal to the old rate, and this is equal to the new rate. And we know the rate, new rate is 4 times the old rate. So 4 rate will be equal to 4 raised to the power of n into rate. That means the value of n is equal to 1. Okay, so it's a first order reaction. Okay. So all of you who are getting it as option C, that second order reaction, you can recheck what you have done. So this is how the first, so this is how the what I wrote in the previous slide. So here, so both of the methods are correct. You just have to find the value of n. This is clear to everyone?
Madam, video not visible to madam.
I have closed the video for saving the bandwidth. The slide is visible, right? Anyone has any doubt in this question? Okay. Okay, then we can move on to the next question. A reaction has been found to have an activation energy of 25,000 calories per mole and a specific reaction rate constant of 5 per second at 27 degrees Celsius. Calculate the specific reaction rate constant at 0 degrees Celsius given the value of R, that is the gas constant, as 1.98 calories per degree per mole. So in this question, in this question we have to use a different formula. So we have the activation energy given and we have the rate constant given for a particular temperature. Okay, and we have to find the rate constant at a different temperature. Okay, so there's another formula. The formula is log K2 upon K1 is equal to activation energy divided by R. R is the gas constant, multiplied by 1 by T1 minus 1 by, sorry, so 1 by T1 minus 1 by T2. Okay, so this is the formula. So we have the activation energy given. We have the gas constant given. We have the T1 and T2. The main thing to remember in this equation is you have to write the temperature in terms of Kelvin. Okay, so 0 degree Celsius is equal to 273 Kelvin, right? So 27 degree Celsius will be equal to 273 plus 27 Kelvin. Okay. So just calculate the temperature in Kelvin and then solve this. So you have the value of K2, you have the value of K1, you have the value of T1, you have the value of T2, you have the value of EA and R. So you have to solve for K2. So here you can see you have the activation energy, so that is the EA. Specific rate constant, that is K1, is given as 5, and the temperature T1 is 27 degrees Celsius, that is 273 plus 27, so this will be equal to 300 Kelvin. Okay, so you can write it as log K2 by 5 is equal to 25,000 by 1.98 multiplied by 1 by 300 minus 1 by 273. Okay, so now you can solve for K2. So if you take the log on the other side, this will be equal to e raised to the power of the whole thing. Okay, e to the power of 25,000 by 1.98 multiplied by 1 by 300 minus 1 by 273. So just a bunch of calculation. Request all of you to do the calculation. Let me know if anyone is able to solve the question. Everybody try to do the calculation. Then only you will be able to understand the question. And it would be a good practice for you also. Anybody is able to solve this? Let me know the problem you are facing in solving this. Are you not able to see my screen? Am I audible? Hello? Okay, good. Nobody could solve this. Okay, I'll show the solution then. The solution, the answer is 0.08 second per second. That is option A. So you just have to do the calculation. Divide 25,000 by 1.98 and then solve the bracket part, that is 1 by 300 minus 1 by 273. Solve this whole thing. Then just take the whole take the whole thing as a power of E. The value of E I told you is 2.7. Okay, E is equal to approximately 2.7. You can, in your calculators, you will find uh, the value of E also. You can just take the power of E for the whole thing and then multiply it by 5. Okay. So the correct answer is 0.08 per second. That is option A. This is clear? I'll move on to the next question now. The aerobic decomposition of hydroxylamine, that is NH2OH, follows the rate expression of the aerobic decomposition of hydroxylamine, that is NH2OH, follows the rate expression as rate is equal to K, concentration of NH2OH multiplied by the concentration of oxygen. Let K let K is equal to 0.096 into 10 raised to the power of minus 3 liter per mole per second at 27 degrees Celsius and 1.04 into 10 raised to the power minus 3 at 50 degrees Celsius. Calculate the EA, that is the activation energy. So what all do we have? We have a rate equation and then we have the rate constants at two different temperatures. So from the previous question, now you know the formula. If you have two different rate constants at two different temperatures, you can easily solve for the activation energy. So what you have to do, log K2 upon K1 is equal to EA, that you have to solve, upon R multiplied by 1 by T1 minus 1 minus 1 by T2, right? So 1 by T1 minus 1 by T2. And the temperatures you have to take in Kelvin. So what are the two temperatures? So if K1 is 0.096, then T1 is 27 degrees Celsius. So 27 degrees Celsius means 273 plus 27 is equal to 300 Kelvin, and K2 is 1.04, then T2 will be 50 degrees Celsius. So 273 plus 50 would be 323. Okay. Then you can solve for EA. The value of R here will be 8.314. So everybody do the calculation. So you have the K2 given, you have the K1 given, you have the R. So R is a gas constant, so it's a fixed value. Generally, the values of R is given in the question. In the previous question, since it was in kilocalories, so the value of R was in terms of calories. Here, the value of R, so in this question, the value of R was in terms of calories. But in this question, the value of R is in terms of joules. Since in the option we have the answers in terms of joules, so the value of R also you will have to take it in joules. So do the calculation quickly and tell me the correct answer. Everybody try to do the calculation on your own. Okay, I'm getting answers now. Very good. So I have D and C as two competitive answers. Let's see. Anyone else is able to solve this? So K2 is 1.04 into 10 raised to the power of minus 3. K1 is 0.096 into 10 raised to the power of minus 3. So if you divide it, then it will be 1.04 divided by 0.096, right? And then take a log of that, natural log of that. So I'm getting 2.38. Now this is equal to, please keep your mics unmute unless you have to ask any questions. It causes disturbance in the class. Okay, now I'm getting option C. Let's see what the answer. C is correct. Also, so you have to relate the value. Very good. So I can move to the next question then. If the first order rate constant for bacterial decay is 0.2 day inverse at 20 degrees Celsius, and if an A for the equation K2 is equal to K1 A raised to the power of Q minus T1 of 1.035 is assumed to describe the temperature on the rate constant, what are the first order decomposition rate constant at 30 degrees Celsius and the value? So here, this is again, you have to use the same formula that we were using in the previous question, but before that, you have to first uh, find the value of K. So first you have to find the value of K and then you have to find the value of EA. So two things you have to solve, right? So here you have K1 given. So for a first order reaction, you have the K1 at a particular temperature, that is T1. Okay. Again, you have to convert it into Kelvin. So in Kelvin, this will be 273 plus 20. So this will be equal to 293 Kelvin. Okay. And from this equation that is given here, you can solve for K2, right? So you know the T2, you know the T1. So K2 is equal to K1. What is K1? K1 is 0.2 into A. What is A? A is 1.035 raised to the power of T2 minus T1. So please unmute your mic if you don't have to ask anything. So T2 minus T1, just take the temperatures in Kelvin. Do not forget to convert the temperatures. So T2 will be 300, T1 will be 293. Okay. Not 300, 273 plus 30. So this will be 273 plus 30. So this will be 303, right? So just solve this and you will get the K2. Once you get the K2, again you can use the same formula that we used in the previous question. That was log K2 by K1 is equal to EA by R. So R you can use since the answers are given in joules. So you can use the value of R as 8.314. EA by R 1 by T1 minus 1 by T2. Okay. So this is the equation you can use once you find the K2 from here. So you will get the value of K2 and you will get the value of EA. Anybody is able to solve this? Okay, we have one answer. Option B. Anybody else? Okay, again, one more answer. Option B. Everybody try to solve the question. Seems to find option B as the correct answer. So let's see. So, please do not unmute your mic unless you have a question. So all of you have solved it for option B. I think there's some calculation mistake that all of you have made. Just recheck your calculation again. So for the first part, that is K2 is equal to K1 A raised to the power of T2 minus T1. So T2 minus T1 will be so 273 plus 30, 303 minus 293. This will be 10. So K2 I am getting as 0.282. How all of you are getting 0.252? Just recheck your calculation, everybody who has answered option B. Recheck your calculation once. So option C is the right answer here. I'm getting K2 as 0.282. And then once you get the K2, you can solve for EA. Anyway, there's only one option with K2 is equal to 0.282. So that would be the correct answer. Recheck your calculation. You should get the answer. You should get the value of K2 as 0.282. And once you solve for EA, that should be 25.36. Are you getting this answer? Naveen or Suvartha? Whoever has written option B, are you getting this answer? Okay, just check your calculation. So the formula that has to be used is this, and you can just confirm your calculation. There must be some calculation error. That's why you might be getting the values wrong. So I hope the question is clear to everyone. I'll move on to the next question. Do you have any doubt in the previous question? Anybody has any doubt in the previous question? Then let me know. Okay, then I'll move on to the next question. Question number 16. A sample is known to have a maximum absorbance at a wavelength of 356 nanometer. Its molar absorptivity is 7200 liter per mole per centimeter. The width of the cuvette is 1 centimeter. And the spectrophotometer finds the absorbance equal to 0.6. What is the concentration of the sample? So this is based on a law called Beer-Lambert's law. So here, whenever we take the absorbance of any solution at a particular wavelength, it follows this Beer-Lambert's law where the absorbance is directly proportional to the concentration of the solution, and absorbance is also directly proportional to the path length. So what do we mean by path length? So whenever we are measuring the absorbance, so we take the solution in a cuvette. So the path and the light passes from one side of the cuvette and uh, emits from the other side of the cuvette. Okay. So whatever solution is there in this cuvette, the solution will have certain absorbance at a particular wavelength. So in this case, the wavelength that we are using is 356 nanometer. So when 356 nanometer light is passing through this solution, some of the light will get absorbed by the solution and rest will be transmitted. So let's say 70% of the light gets absorbed by the solution. So if 100% light is getting like passing through the solution, only 30% will be transmitted. So whatever is transmitted, based on that, how much is absorbed, that is calculated. So that's how you get the absorbance. and that absorbance is directly related to the directly proportional to the concentration. So higher the concentration, more the absorbance, or lesser the concentration, lesser will be the absorbance. Okay. And the absorbance is also directly proportional to the path length. So path length is the length of the cuvette through which the light is passing. So light is passing from this point to this point, right? So this is the path length of the light. So here the width of the cuvette is 1 centimeter. That means the path length is 1 centimeter, and absorbance is given. We have to find the concentration. So since these two things are directly proportional, we can write it as A is equal to epsilon multiplied by concentration multiplied by path length. And epsilon is the proportionality constant. It is also known as molar absorptivity. So here you have the molar absorptivity. This is denoted by the symbol epsilon. Okay, it's a Greek symbol. It looks like E. So this is the molar absorptivity or molar extinction coefficient. It is also known as molar extinction coefficient. So the value of epsilon is given as 7200. Concentration we have to find. The length is 1 centimeter and the absorbance is given as 0.6. Okay. So now you know the absorbance, you know the epsilon value, and you know the length. So you can easily solve for the concentration. So you have to just divide 0.6 by 7200. This will be equal to the concentration. This is clear to everyone? Just divide
ठीक है
0.6
ठीक
by
है ठीक है
just divide 0.6 by 7200. Option B is the correct answer. Yes. 8.3 into 10 raised to the power of minus 5. Okay. So this is the Beer-Lambert's law I was talking about. So absorbance is equal to the epsilon value, that is the molar absorptivity or molar extinction coefficient, multiplied by the length of the cuvette, multiplied by the, sorry, length, this is the path length of the light. So this is denoted by the width of the cuvette, and this is multiplied by the concentration. So concentration you have to find. You have the absorbance, you have the molar absorptivity, and you have the width of the cuvette given. Okay, this is clear. We can move on to the next question, that is question number 17. What are the functional groups present in 4-aminophenol? So 4-aminophenol, what are the functional groups present in 4-aminophenol? So you have in the name, you can see it is amino and a phenol. Phenol means a benzene ring with an OH group. So the functional groups that are present are one amino group and one phenolic group. So uh, this is how 4-aminophenol looks. So you have, so this would be the first position carbon. So this would be the first position carbon. So 1, 2, 3, 4. So on the fourth position, you have the amino group. So 4-amino, and this whole group, molecule is called phenol. So when you have a OH on the benzene ring, it's called phenol. Okay. So 4-aminophenol. So the functional groups are primarily the hydroxyl group OH and the amino group at the fourth carbon. Okay, one amino group and one phenolic OH. Okay, the next question is, what is the unit of rate constant of a second order reaction? What is the unit of the rate constant of a second order reaction? This is an easy question. You all can answer this. Can you all answer this? Yes, option D. That is the correct answer. Very good. So option D. So how do we calculate the rate constant for a second order reaction? I told you the rate of a reaction is given as, yeah, the rate of a reaction is given as A multiplied by the reactant concentration raised to the power of N. So in this case, the value of N will be 2. So now the rate is moles per liter per second. Okay, because the change in concentration, so concentration is given as moles per liter, right? So change in concentration per unit time. So rate is generally written as dc by dt or da by dt, right? So change in concentration per unit time, and this will be equal to K, and concentration is again given in mole per liter, and you will have this as whole square. So 1 mole per liter will get cancelled out, and you will have liter mole inverse second inverse, the unit of K. Okay, so that is option D. Okay, so all of you answered it correctly. So this is the last question. 2,4-D, which is a herbicide, in aqueous solution shows its lambda max in the UV range. We want to measure the absorbance at its lambda max. So lambda is the wavelength. Okay, so the maximum wavelength at which 2,4-D is showing absorbance is in the UV range. Okay, so if we want to measure the absorbance at its maximum if we want to measure the absorbance at the wavelength at which it has the maximum absorbance, we must use a cell or a cuvette made of option A glass, option B plastic, option C quartz, or option D any one of the above is okay. So for UV, we have to use a particular material. So yes, we have one answer, C quartz. That is the correct answer. So we cannot use any cuvette when we are when we are measuring the absorbance. So if you are measuring the absorbance at a visible range, that is the wavelength that is in the visible range, then you can use glass, plastic, or quartz cuvette. But if you have to measure the absorbance at a wavelength that is in the UV range, you have to use a quartz cuvette. Otherwise, the glass and plastic can absorb the UV light. Okay. This is clear. So glass and plastic can absorb in the UV range, so you won't get the exact absorbance. So we are trying to measure the absorbance here, right? So since we are trying to measure the absorbance, and if the cuvette material is also absorbing, then we won't get the absorbance of our solution properly. We won't get the absorbance of the 2,4-D solution properly. That's why we need to use quartz and not glass or plastic cuvette. Okay. So this was the last question of the session. So anybody has any doubt? If you have any specific or in section of the lecture, if you have any doubt, I think you can end the session. End the session. Thank you everyone for joining. I'll see you next Tuesday. Thank you everyone. Bye bye.